Hi, this is Mr. Manley, and in this video I will be converting between degrees and radians. These are two different ways of measuring an angle, two different units of measuring an angle. Just like if I were taking a unit of length and I could say how many inches is this, and that would be one unit of measure, and I could say how many centimeters, and that would be another unit of measure. There are 2.5 centimeters approximately, I think it's 2.54 something centimeters per an inch. So I could set up that relationship between inches and centimeters. Likewise, I can set up a relationship between degrees and radians. There are 360 degrees in 2 pi radians. And hopefully that 2 pi should be something that you kind of feel familiar with. Remember when you learned the circumference of a circle, that the circumference of a circle is equal to 2 pi r. And then here we have this idea that 2 pi radians is equivalent to 360 degrees, which I know as a whole circle. So this should be a relationship that's not too difficult to commit to memory or to understand if we were to go into why the units relate the way they do. And then I'm also going to go ahead and just divide both sides by 2 and say this is commonly the way that I'm going to express the relationship, that there's 180 degrees and that's equal to pi radians. What we want to be able to do is if we're looking at degrees, we would want to be able to know how many radians is that if we needed that information. And likewise, if we were looking at radians, we would want to be able to convert that degree to degrees. One other thing that I think if you're in Precalculus that you know is that pi radians, the number pi we know as approximately 3.14, right? And there's a simple reason for that. I think we can take time to go ahead and look at that for a moment. The 3.14 comes from a circle, and if I took the radius, or I should say the diameter, if I took the diameter of the circle, and then if that were flexible, if that diameter were flexible and I could wrap it around the edge of the circle, it's going to wrap around approximately 3 times, and then there's going to be just 0.14 left over. So that's what that 3.14 means. It means how many times does the diameter wrap around its circle. So at any rate, I've got this angle, negative 6 pi over 17. What we really want to do here is do this conversion to degrees. I want to convert this radian measure to degrees. So in order to do that, I'm just going to use that relationship that I've already established back here, that there's 180 degrees for pi radians. And that'll be a simple multiplication problem where I'm multiplying this many radians times, and then I want to multiply by the number of degrees over the number of radians, which we saw on the previous page to be 180 degrees per pi radians. And that way the radians will cancel, and I'm going to be left with units in degrees. Sometimes these are convenient numbers and we can simplify these pretty easily. Other times we might want to do a calculator key in. In this case, we're going to round our answer to the nearest hundredth. So we'll add that up here to the nearest hundredth. And it'll be a calculator key in. And with that calculator key in, also notice we're going to cancel this pi over this pi. And after keying that into the calculator, we're going to get negative 63.53 degrees. And that'll be to the nearest hundredth. So negative 63.53 degrees is equivalent to negative 6 pi over 17 radians. Okay, so that's from radians to degrees. Let's take another look at radians to degrees. The only difference here, this is not that big a deal, is that this is given in, it's not given in terms of pi. So I don't know what relation this has to pi radians, but that doesn't make the calculation any more difficult. It actually makes it easier. I just need to go 10.26 radians times 180 degrees over pi radians and do my calculator key in. Canceling radians, I'm going to end up with degrees. And with the calculator key in, I'm going to get 129.554 degrees. And here we're going to be asked to round to the nearest hundredth. So the answer would be 129.6, nope, hundredth would be 5 degrees. And that is how many degrees are in 2.26 radians, which makes sense if we consider that a radian is a radius. So if I take the radius and I wrap it around the circle 1 time, 2 times, and then another quarter of time, I'm going to end up somewhere around here, which looks like 129 degrees or thereabouts. Okay, so those are all radians to degrees. Now we're going to look at degrees to radians. So that's 22 degrees. I'm going to convert that to radians. And here when I multiply, I want to have radians over degrees. And then sometimes it's going to be indicated what I want to convert to. Do I want to convert it in terms of pi, or do I want to do it as a decimal approximation? So in this case, I'm going to stick with the nearest hundredth. But I might show you one other thing with that if we weren't going to the nearest hundredth. So what have we got? We've got the pi radians over 180 degrees. That's the relationship that we'll always have. That's our conversion ratio, the ratio that we use to convert. And that will cancel the degrees with the degrees. And then we have a calculator key in. And with that calculator key in, I get 0.38, and I want to go to the nearest hundredth. So that's it, 0.38 radians. Now it could have been, I could have said, instead of saying to the nearest radian, I could say convert to radians, and then it could have said in terms of pi. And if that were the case, then I would have done 22 over 180 pi radians. And then I would have wanted to simplify this 22 over 180. I might do it just simplifying it as much as I can with the exact values. What could I go? 11 over 90 pi radians. And maybe I could do it as a decimal, 11 divided by 90, and get the decimal approximation for that. So I could say 0.12 pi radians. That doesn't really look like a familiar way that I would ever represent this. So, but yeah, for our purposes, nearest hundredth, and it's all a calculator key in, and this is our answer. And those are all the conversions that we could expect to do between degrees and radians, always going back to the relationship that it is 180 degrees, half of a circle, is equal to pi radians, which is half of a circle in terms of radians.